This is group 21, and we are going to be taking it through the traffic control system. Yes. So my name is Atwere Brian, and I'm basically going to take you through the overview of the project, and then my colleagues will do the rest. So our thing is basically to help pedestrians cross the road. The problem we are solving is the difficulty in crossing the road, because now, for example, the case study we are using is outside the western gate. When students are crossing from campus to go back to their hostels, on that road the cars are always crossing very fast, and they find so much difficulty to cross the road because the cars will be moving, and sometimes some students are knocked down there. So what we did here is implement a traffic control system where as a pedestrian, once you're coming or once you want to cross the road, all you will do is press a button. Once you press a button, the traffic lights will turn red, meaning the cars will stop moving, and for a given wait time, which is now 10 seconds, then you'll be given that time to cross the road. That's the time we expect a pedestrian to cross the road. After that time, the traffic sequence will resume. However, in a case where there are more than one people and there are very many people crossing the road, or in this case an elderly person crossing the road very slowly, and let's say the 10 seconds are few for them, we have a sensor that is going to detect whether there is still an obstacle If there is an obstacle, the light will remain red, and then the cars won't be able to move. How we are doing this is we compare the distance, the width of the road, and if it's not complete, as my colleague will tell you, the cars don't move, the traffic light will remain red. Yes, that's basically it. I think my colleague will come and take us through the next. So thank you so much. That's what I have to say.
My name is Ssekyanzi Elvis, Group 21, Embedded Systems. This is the normal traffic light system. As you see the LEDs from red, it takes 10 seconds, then to yellow, then there takes 5 seconds, then to 10. Yeah, this is an implementation of the normal traffic light system. The moment maybe a pedestrian may want to cross, will be able to press the red button. In real time, the red button will enhance the system so that it takes to the red lights or the red LED, and by the serial monitor it will show that the red light has been implemented there, and then the pedestrians will be able to cross. With the project, we have the sensor. In case the pedestrians are still crossing, maybe they are many in number, the sensor will be able to detect whether anything is there that will be the pedestrians, so that it enhances the red light to be pressed, and the red light the system will go back to the red light so that the pedestrians are able to cross for the sensor. And with the serial monitor, the sensor is able to show that there are still other obstacles within the road that enables the pedestrians to cross. The sensor, in detecting whether an obstacle is there, it checks again for 10 seconds whether the obstacle is still there, which in turn will return a message to the serial monitor, and the serial monitor will be able to show whether an obstacle is still being detected, which will enhance the red light to stay on, so that any pedestrians who are still crossing are able to cross very safely. That's how it goes for the traffic light system.
So from my previous colleagues that they have explained, I'm Zach Emerson, and I'm just going to take you through like what each task that was assigned to each board. As board 1, for it is implementing the LEDs, that's the traffic light control, or that's board 1, that's the one that's implementing the LEDs. So board 2, for it, its task is like the sensing objects, as the previous colleagues explained. For that board 2, for its main purpose is to focus on the sensor. So board 3, for it is solving the problem like the interrupt. like having the switch. So when you press it, that's the interrupt sends the information. So for board 4 for it is the EEPROM, that's for storage. Whatever the boards are communicating, it is board 4 that's storing each and everything. So these boards are they're in a position to communicate. They are in a position to communicate because we use the serial communication as it was the requirement. So they are communicating through the TX. Like we connected the TX and the RX. Like the TX is connecting to like for instance the DX of board 1 is connecting to RX of all the 3 boards. Likewise, the RX of board 1 is being connected on to TX of all the boards. Like we have just interchanged in that form. That's to allow the serial communication. So that's how the thing is working, and the serial communication is being implemented. That's how we connected it here. Everything has been implemented here. The GPIOs, that's the connection using the pins here on those boards. We allowed the communication. So in summary, like we have implemented each and everything that was required of the ADC. That's the ADC. We use the sensor, that's body 2. And like the interrupts, that's the switch, board 3. Then the EEPROM, we use the board 4. And then the serial communication, which the TX and then the RX to allow all the boards to communicate, like to receive and then they transmit the data. So that's what we did. So we use the bush pattern for the implementation of like to incorporate the bush bouncing. We use the bush pattern for body 2. So in conclusion, that's how the project has been, and everything has been in that. Thank you. So he's taking us through what we did, the output on the serial monitor. That's how things are appearing. Yeah, and everything is working perfectly, as you can see. All the 4 boards are communicating very well.